All right, welcome. Today, we're going to kick things off with a super simple game. But trust me, this little game reveals something so powerful, it might just make you question what you're seeing with your own two eyes. We're talking about an incredible optical illusion that, believe it or not, shapes our entire planet.
Okay, so picture this. You're on a merry-go-round, one that's been specially set up to spin counterclockwise. And the game, it's just a simple game of catch. You're just trying to throw a ball to the person sitting right across from you. Super straightforward, right? What could possibly go wrong?
So, let's really put you in the hot seat here. You've got the ball. You throw it in a perfectly straight line, aiming right at your friend. But remember, the entire platform is spinning underneath you. So, where does the ball actually end up? Take a second. What's your guess?
Well, when this experiment was actually done, the predictions were all over the map. I mean, you had one guy who thought he'd throw the ball and somehow end up catching it himself. Another was totally convinced it was going to veer off to the left. And then you had the optimist who was like, nope, it's just going to come straight to me. Obviously, they can't all be right.
All right, moment of truth. Let's see what really happened. The ball is thrown, the merry-go-round is spinning, and what happened next? Well, it pretty much shocked everyone.
So get this. The ball didn't go straight. It didn't go left. And no, the thrower definitely didn't catch his own throw. Instead, it landed right in the hands of the person sitting to the thrower's right. From the perspective of everyone on that ride, it looked like the ball took this huge, impossible curve through the air. And just listen to what the thrower said afterwards. He was so sure he threw it straight, but he described it as if the ball just curved, like it got sucked over to the other guy. It felt like some kind of weird magic, like an invisible force just grabbed it out of the air. But that really gets to the heart of it, doesn't it? Did the ball actually bend its path in midair? Did it just decide to ignore the laws of physics? Or was something else going on entirely? And the answer is, it's all just an incredible optical illusion. What those players were experiencing is a really powerful phenomenon that's happening all around us all the time, and it has a name.
It's called the Coriolis effect. And here's the absolute key to understanding it. It's not a real force pushing the ball. It is an optical illusion. The ball only seems to get deflected because the observer, the person watching it, is in a rotating frame of reference. You're basically trying to watch a straight line while you're moving in a circle. Your brain gets tricked.
And this is where you can really see that disconnect between perception and reality. If you were watching from a drone high above, you'd see the ball travel in a perfectly straight line, no question. But for the players on the merry-go-round, from their point of view, that same ball looks like it's taking a dramatic curve to the right. So let's just walk through exactly how this works, step by step. 1. The thrower lets go and the ball starts traveling in a straight line. Simple enough. But 2, at the exact same time, the merry-go-round is rotating counterclockwise underneath it. This means 3, the person you were aiming for has now moved out of the ball's path, and 4, the person who was on your right has now rotated into the ball's path. So what's the result? An apparent curve to the right. See? The ball didn't curve at all. The target moved.
Okay, but this is way more than just a cool carnival trick. Let's scale this whole idea up, because this exact same principle applies to, well, the entire planet we're living on. I mean, just think about it for a second. Our planet is basically a giant merry-go-round, isn't it? It's constantly spinning. And because of that, its rotation has the exact same effect, just on a massive global scale. So anything traveling a long distance, we're talking wind, ocean currents, even a long-range rocket, is subject to this very same apparent curve.
And what's wild is that there are clear rules to this. In the Northern Hemisphere, where most of us live, any moving object appears to get deflected to the right. But in the Southern Hemisphere, it's the opposite. They appear to curve to the left. And right on the equator, where that spinning effect is at its minimum, there's basically no deflection at all.
So, okay, it's a giant optical illusion on a planetary scale. But why does this matter? Why should you care? Well, it turns out this so-called illusion has incredibly real and incredibly powerful consequences for all of us.
The Coriolis effect is pretty much the invisible hand that sculpts our planet's weather and climate. It's what shapes global wind patterns. It steers massive ocean currents like the Gulf Stream. It is the very reason that hurricanes and huge storms spin into those giant, terrifying spirals you see from space. It even has to be factored into the math for things like long-range artillery shells and missiles, just to make sure they hit their target. It's everywhere.
It's really a pretty humbling thought, isn't it? The path that looks perfectly straight to us is only straight from our own moving perspective.
And it kind of makes you wonder, if our planet's simple spin can create an illusion this powerful and this consequential, what other unseen forces are out there, quietly shaping the world we see every single day?